Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a new topic regarding the sudden closure of valves and the pipe is rigid. So this is a concept in the water hammer in pipes, and in the last lecture I already have discussed the gradual closure of valves, and now we'll discuss about the sudden closure of valves. So before going to the concept of this condition, the pipe is rigid and suddenly the valve will be closed. Let me give a brief intro about this diagram what we have taken here. So this is a diagram like a container is there, or you can say a reservoir or a tank. In the tank or reservoir, suppose let's consider this is a huge tank is there, and this is the pipe. So a pipe of AB is connected to a tank, and in the tank water is present here with a height of you can say h. So this height, actually this is the head at the inlet condition. Okay, inlet of what? Inlet of this pipe. So this pipe is connected, one end is open to the atmosphere, another end is connected to the tank. Okay, so the water which is present here in this large tank, so that will start flowing through this pipe here. Okay, so when the fluid is when the fluid is flowing through this pipe, the velocity need to be considered V, capital V, and diameter of this pipe will be D, and length of this pipe, the total length of this pipe from inlet to the outlet will be L. And at the end of the pipe, a valve is connected to regulate the fluid flow. Okay, so this is the valve, and this is H is there. Okay, so this is all about the diagram. Now coming to the picture here. Previously, as I told you already, we have discussed the pressure value in the gradual closure of valves. Okay, so let me consider that value what we have identified. We got the value of P equal to rho LV by T. So this is the equation we derived in our previous lecture when we have considered the concept of gradual closure of valves. Okay, that means that valve need to be closed slowly. Okay, and here the rho is density, L is the length of the pipe, V is the velocity of the flow, and time T equal to the time taken to close this valve in second. So these are the parameters are there. Now when you are discussing about this sudden closure of valves, that means this valve is there and that is going to be closed suddenly. Okay, actually this equation what we have taken, this equation or what we have derived in our last lecture, what it defines that increase of pressure, if see this is the pressure term is there, increase of pressure due to water hammer in the pipe, and the time required to close the valve, that depends, it depends on the water hammer in the pipes and the time required to close the valves. Okay, but see the time is taken to close the valve, some time will be taken, suppose 1 second, 2 second, 3 second, 5 second, 10 second. But when T will be 0, when T will be, the time taken will be 0, this one, when time taken will be 0. What about this value? This value is going to be, the pressure is going to be infinite. Okay, the pressure is going to be infinite as per our formula. Okay, now because see time T, why I have taken 0? Because we are going to close the valve suddenly, not gradually. Gradually means it will take some time, T equal to 10 second, 20 second, 15 second, different timings like based on your performance and speed. Now when you consider the time T equal to 0, that means suddenly you are closing the valve without any fraction of seconds, like immediately we are closing the valves. So in that point of view, what will be the pressure value? Now we'll get the pressure of infinite. This is as per the formula it's saying. But actually from the experiment, it is observed that the increase of pressure actually is due to water hammer is finite. Due to the water hammer is finite, that means some value is there, not infinite. Okay, so pressure value, how the pressure increasing, actually due to the water hammer is finite, some value is there. Even if you close the valve suddenly, even if you close the valve suddenly, there will be a finite value will be there, some number will be there here. Okay. Now this equation what is says, which was valid for only when the liquid is or when the fluid is incompressible fluid. It will be valid when the fluid is incompressible. We need to keep in mind. That means the fluid is not compressible. The fluid is not compressible, such as water. And second thing, when the pipe is rigid. When the pipe is rigid. Two conditions are there here. Pipe is rigid. Rigid means what? Rigid means it is very, very strong. There is no change in the shape and size. Now, this is the condition. Only this equation will be valid only when the fluid is incompressible and when the pipe is rigid. This pipe, we're talking about this pipe AB. Okay. Now, again, when you suddenly close this one, there will be a wave formation will be there, and that will be create a high pressure. As I told you also previously, when you close the valve suddenly, because we are obstructing the fluid flow, which was flows at a velocity of v, and suddenly we are closing, means there will be a wave of high pressure will be created definitely. So that liquid will be slightly compressed. The liquid will be slightly compressed on some little level. You can say up to some extent it can be compressed. Okay. And the pipe may be, this pipe may be stretched. So here two things again came. One thing is the liquid at some extent it will be compressed. It will be compressed, and the pipe what I mentioned here, that will somehow stretched. Somehow it will be stretched. For sudden closure of valves like this one, for sudden closure of valves, we can consider two different conditions, or two different conditions need to be considered for sudden closure of valves. So one is sudden closure of valves. Sudden closure of valves. Okay, when the valve, when the pipe is rigid. Sudden closure of valve, one thing, and in that condition the pipe is rigid. The pipe is rigid, as I mentioned here initially. Then second condition is the sudden closure of valve. The sudden closure of valve when, that means another one condition, the pipe is elastic. The pipe is elastic, because these two new term came here, as I told you, because due to the sudden closure of this valve, there is a wave, high pressure wave is formed here, and due to this high pressure wave, there is some extent of compressible fluid will be formed here. So that's why the fluid will be compressed, and there will be this pipe is going to be stretched. So two conditions can be considered for this. One is, as I told you, the sudden closure of valve, pipe is rigid. Another one is the sudden closure of valve when the pipe is elastic. Now in this we'll discuss about the sudden closure of valves and pipe is rigid. Okay, so as I told you already, let's consider this is the AB pipe is there, and the pipe is rigid. The pipe is rigid in the sense we need to understand that the pipe is not going to change its shape and size. Okay, and it is going to be strong and stable. There is no change in the shape and sizes. That is the meaning of rigid. So here some terminology also need to be considered. Already I have mentioned here previously, like one is A. Area of A equal to area. A equal to area of pipe of this AB pipe. Area of the cross section of the AB pipe we can say. L equal to the length of the pipe. L equal to the length of the pipe, and V equal to the velocity of fluid. The velocity of fluid which is flowing through this pipe, that is V, and P is the intensity of pressure. P is the intensity of pressure, and one more term you need to consider here, K, that is bulk modulus of water. That is bulk modulus of water we need to consider. Water. Okay, now These are the terminology I have considered here. So let's start the derivation for this. Now, when the valve is suddenly closed, actually, see, when the liquid or when the fluid is flowing through from the tank to the pipe, we have a pressure energy and kinetic energy is there. We have a pressure energy and kinetic energy. And if you connect a nozzle to this one, then the pressure energy will be converted to the kinetic energy. So from the nozzle, the total energy will be converted to kinetic energy, and with a high velocity fluid will come out from here. Now here we know that the pressure energy and kinetic energy is flowing through the pipe. Now when you close the valve suddenly, the kinetic energy of the fluid water, the kinetic energy of the fluid which is present in the water, that is going to be converted into strain energy. So the kinetic energy of water is going to convert into strain energy. I'll tell you what is strain energy. Strain energy of water. Okay, of water. Again, one more thing. We need to consider that the effect of friction is negligible. That need to be neglected. And as I told you, the pipe need to be considered as a rigid. So the total kinetic energy is going to be converted into strain energy of water. And here two more assumptions need to be considered. As I told you, one is losses. Losses, you can say losses, major loss is negligible, or you can say the friction is negligible. And the second one is the pipe is rigid. These 2 points we need to consider here. Yeah. Now, so what are the losses happened here? As I told you, the loss of kinetic energy. So now we need to identify the losses of kinetic energy equal to, we know that kinetic energy equal to half into mv square. So half into m into v square. So m equal to the mass of water which is present in the pipe. So mass of water in the pipe, that we can write m equal to, we know that rho equal to mass by volume, and here we can write mass equal to rho into v, rho into volume, and volume place we can write area into length. So A into L we can write. So here also same thing I'll mention here. This is half into rho A L into V square. Okay, give this equation 2, because already equation 1 I have mentioned here. So let's consider this is equation 2. Now this loss of kinetic energy, because here we are stopping this one, so kinetic energy is stopped here. Now this kinetic energy is converted to strain energy of water. So that means there is a benefit towards the strain energy. So what is strain energy actually? The strain energy is nothing but the energy stored in a body. The energy stored in a body due to some kind of deformations. Okay, so that is strain energy. So though this kinetic energy losses we have identified, and the kinetic energy also converted to strain energy, so there is a gain in strain energy, you can say. There is a gain in strain energy. So strain energy, actually the formula is U equal to half into sigma square by epsilon into V. So like different terminologies are there. So somewhere, because it is also used in the in the dynamics case also, we can use strength of material also, we can use that one. So here we'll consider the gain in strain energy, that will consider half into, so here intensity of pressure P square into K into volume. So here this K part need to be considered Valsalva modulus of water. Even in some cases, as I told you, like we can consider half into sigma square epsilon into V. Similarly, this is also formula is there, strain energy. Even same thing we can write in this way also. Okay, P square by K into V. So this is another equation 3. Now as per our definition, the losses of kinetic energy, okay, the total energy is converted to strain energy. So let equate this loss of kinetic energy to gain of strain energy. By equating these two equation, what we can get, what we can write here, half into rho into L into V square equal to, here also we'll get half into P square by K into V. So here half is there, we can cancel that one. Our intention is to find out the value of P, the intensity of pressure here. So anyway, so first let's cancel this 1 by 2 terms. And here we can write this is P square by K. So let write here P square, and other side we can write this is rho AV. So rho A, here V is there, so we can cancel V also. So only one V will be there. So rho A L V, rho A L V by K we can write. Okay. So this is half mv square. Here v square is there. Anyway, v square is there, and this side we have the half into p square by k into v. V is the volume here. Here it is actually velocity. Here is volume. So here volume also we can write in this cannot be cancelled here actually. So now this one again we can write volume in terms of area into length. Area into length can be written here. So now length can be cancelled, okay, and area can also can be cancelled. So L will be cancelled, and here as usual V square will be there. There will be no cancellation on V square, okay, and here K is there, so K will become this side. Now finally what I'll get here, let me write this final equation here. P equal to P square, here it's there. Now let me write in P equal to root over of this rho is there, A cancel already, L cancel already, rho into V square into K. This is the pressure term. Now here again we can write this is like let take this V square V term outside, so we can write V equal to V into rho into K. Now here again just I'll convert this term in simple ways. P equal to, let me write the final equation, rho VC. This is the final equation number 4. Now you will be confused, so how this equation came, like here already is there, only V is there. Now rho C, how it came, actually the C term is nothing but we can write root over of K by rho, So here if you see V into root over of Kp was there, K rho was there. Now you can write in this way, okay. So this one, like let me write one more step here, like V into, we can write root over of K rho square by rho. Just I have multiplied one row here and divided one row here. Now this K by this part I can write C. Again rho is there, so we can write root over of rho square rho, and velocity V already there outside. So finally we can write this is our pressure term. And here what is the term of C? C is nothing but the velocity of pressure wave. C equal to the velocity of pressure wave. So I hope you understand when the valve is closed suddenly and the pipe is rigid, then what is the final pressure will be there, how the pressure affecting. So this is the term P equal to rho into V into C. So this is the equation is there. So how you got the equation? We need to start from the previous equation what we got. Then you can understand why it is not valid and for which condition it is only valid. And from that we can start it. This is two conditions are there. So in this lecture we have discussed only this part, the sudden close of valve and the pipe is rigid. In the next lecture we'll discuss about the second terminology. So I hope in this lecture you understood all this concept. If still you are having a doubt and query regarding this, you can give a comment on the comment box. Thank you all.